Question 14 shows the eyepiece reticule and also the stage micrometer in the figure here. And it is using the eyepiece reticule to measure the cell. So obviously, these questions is related to measuring the cell using the eyepiece reticule. So it is measuring cell type. So to solve this question, we can just follow the 3 steps. In step number 1, we will find one pitch on the stage micrometer first. So meaning that the first step, we have to figure out this one pitch. This one pitch on the stage micrometer is equals to how many micrometer? So that is always our first step. So to calculate that, we need to look at the questions. So from the questions, we see that they are using a stage micrometer that is 1 mm scale. That is 1 mm scale. So it also did not state that the questions does not state that the stage micrometer is special or having a total number of how many divisions, right? So that will means that this stage micrometer is a normal one, a normal stage micrometer with 1 mm scale. So based on this, we can just write that 100 pitch on the stage micrometer is equals to 1 mm. Yeah, because all the normal stage micrometer will always have 100 pitch. Yeah? So first thing first, we need to change the millimeter to become the micrometer first. So to change that millimeter, we need to times 1000, that it will become micrometer. So now it is 1000 micrometer. So we will do the conversion here. So 100 pitch on the stage micrometer is equals to 1000 micrometer. So that will mean that one pitch on the stage micrometer is equals to 1000 micrometer divided by 100. So one pitch is equals to 10 micrometer. So with that, now we know that this one pitch on the stage micrometer is equals to 10 micrometer. Then what is next? Next will be step number 2. Step number 2 is we need to find one pitch on the eyepiece reticule. So we need to know this one pitch. This one pitch on the eyepiece reticule is equals to how many micrometer? That is our step number 2. So step number 2, it would be find one pitch on the eyepiece reticule. So how to do this step number 2? Well, we have to start with finding two overlapping lines. We need to find the overlapping line of the stage micrometer and the eyepiece reticule. So this would be the first overlapping line, and this is the second overlapping line. So we can see that the line of the eyepiece reticule and the line of the stage micrometer, they are overlapping perfectly here. So we will take these two lines. So I will highlight that. So we will take these two lines starting from here until here. So from these, we can see that this is one pitch, two pitch on the eyepiece reticule. Yeah, this is two pitch on the eyepiece reticule, and it's equal to one pitch, 2, 3, 4, 5 pitch on the stage micrometer. So it's equals to 5 pitch on the stage micrometer. So once we know this, then this is how we start our step number 2. So 2 pitch on the eyepiece reticule, like what we get from the figure A above, okay, is equals to 5 pitch on the stage micrometer. So just now we have calculated that one pitch on the stage micrometer is equals to 10 micrometer. So that's why we will replace it here. So that will mean that 2 pitch on the eyepiece reticule is equals to 5 times 10 micrometer. So 2 pitch, so we can change to 1 pitch already. So 1 pitch on the eyepiece reticule will be equals to 50 micrometer divided by 2. So 1 pitch on the eyepiece reticule is equals to 25 micrometer. So with that, we know that this 1 pitch on the eyepiece reticule is equals to 25 micrometer. Okay, so this would be the step number 2. Yeah. So before we proceed to step number 3, obviously this eyepiece reticule scale and the stage micrometer scale is a bit different here, because normally when we do the this type of the questions that measuring the cell using the eyepiece reticule, normally the eyepiece reticule scale, that means 1 pitch on the eyepiece reticule is normally smaller than 1 pitch on the stage micrometer. Yeah, normally it should be smaller, but obviously this question is a bit special. Yeah, so the eyepiece reticule that they use is also quite special. You can see that it is quite huge. Yeah, the 1 pitch on the eyepiece reticule is quite huge, which is 25 micrometer. Is way larger than the pitch on the stage micrometer. So that's why in this question it is stating that this eyepiece reticule is special. Yeah, it's a special one. Okay. But well, sometimes the questions will tend to ask in this type of situation, or ask with using the special eyepiece reticule or sometimes special stage micrometer. So that's why we have to be alert when it comes to this type of question. So next we will continue with step number 3. So step number 3 is where we use the eyepiece reticule to measure the cell. Measure the size of the cell. Yeah. Okay, so that would be step number 3. Yep. So to measure that, of course, we will use the eyepiece reticule scale. We will use the eyepiece reticule scale to measure the cell. So, but again, this question is a bit special because first thing first, they don't tell us how many cells they measure or how many eyepiece reticule scale they can measure for one cell. Okay, but what they do is they show us figure B. Yeah, they show us the figure B. So for figure B, this is the eyepiece reticule. Yeah, or this line is actually the scale or the line of the eyepiece reticule. Okay, then based on this, based on this question, you can see that figure A and figure B. Yeah, so figure B is showing the eyepiece reticule, and it is the same eyepiece reticule. And figure A and figure B are under the same magnification. So if let's say they are under the same magnification, so that means that this one pitch of the one pitch of the eyepiece reticule is the same, is 25 micrometer. It would be same size, even though in figure B it look larger. Yeah, as you can see, figure A is so smaller, but figure B is so it seems to be larger. But then the question has stated that both figure A and figure B are at the same magnification. Yeah, so figure B, they basically enlarge it for better visualization only. Yes, but they are still under the same magnification. So that means that this one pitch on the eyepiece reticule will be same in figure A and figure B. So once we know that, then we can use this eyepiece reticule pitch to measure the cell. But like what I mentioned just now, these eyepiece reticule is quite special because they are actually quite huge. Yeah, they are actually quite huge. Okay, and because the one pitch of the eyepiece reticule is bigger than normal, so that's why we can see clearly in the picture. We cannot use the eyepiece reticule to measure the size of one cell at all, because obviously all the cell here is smaller than 25 micrometer. They are smaller. So that means that they are not able to fit in the whole pitch at all. Okay, so that means that, yes, we need to figure it out. Yeah, we need to figure out a way how to measure it using this special eyepiece reticule. So how we can measure that? Well, we can see how many cells can fit exactly into the pitch of the eyepiece reticule. Yeah, we need to see how many cells can fit exactly into the pitch or pitches of the eyepiece reticule. So in other words, we need to find the cell that align perfectly. Yeah, that align perfectly on this line of or scale of this eyepiece reticule. So from here we can see that obviously this cell cannot, because they are not aligning perfectly on the line. Yeah, so this one also cannot. So we can see this one is aligning perfectly. So this is your starting point. Okay, this is a starting point. So 1 cell, 2 cell, 3 cell, 4 cell, and at cell number 4, they align again perfectly with another scale or scale line of this eyepiece reticule. Okay, so based on this, right, we can now know that 1 pitch, 2 pitch, 3 pitch, it is 3 pitch on the eyepiece reticule equals to the length of 4 cell. Yeah, 3 pitch on the eyepiece reticule equals to 4 cell. So once we know this relationship, then now we can quickly write it down. Okay, so it take like 4 cell. Yeah, 4 cell, the length of 4 cell. Maybe I can write it clearer. So the length of 4 cell is equals to, is equals to 3 pitch on the eyepiece reticule. So like what we calculate just now, 1 pitch on the eyepiece reticule is equals to 25 micrometer. So we will substitute here. Yeah, we will sub here. So that means that this length of 4 cell will be equals to 3 times 25 micrometer. So that will mean that it's 75 micrometer. Yeah, 75 micrometer. Okay, so how about length of 1 cell? So length of 1 cell. Okay, so this one we'll just put it in. Okay, length of 1 cell, it will be equals to 75 micrometer divided by 4 cell. So what we get, length of 1 cell would be 75 divided by 4. That would be 18.75 micrometer. So the way, the step to solve this type of question, the measuring cell type, it is still the same. It is still step number 1, step number 2, and step number 3. And so that is just that, for step number 3, sometimes, or some of the step, we might need to modify a bit so that we can answer, based on the modification of in the questions.